Our short session will be based on just 3 papers. To start with, we're going to look at 4 topics. Number 1, we are dealing with what we call descriptive statistics. So we'll be given a table that shows marks that we obtained for applicants for a job. And these are arranged from the smallest to the highest. So you'll be asked to find our mean. The mean of the data is simply adding up everything and dividing by the sample size. So for such questions, those of you I taught to use a calculator, you can simply punch them by going into standard deviation mode and entering all the variables. Because you take a lot of the time to calculating the other aspects. So once you enter everything into your calculator, your output should look something like this. Okay, so we have our summation of x will be 1136. Summation of x squared is 46,534, and our n is 30. So after finding that, it will be easy for you to do the computations. Of course, your calculator will find everything, even the mean and the standard deviation. But you show your workings. Summation of x over n is our mean, 1136 over 30, we get 37.867. And the variance. Now, this variance in this case was population variance. How do we know it was a population variance? When you go to our question to say applicants for a certain job and an aptitude test. So this is a set of all the applicants that came through. So we're using population variance. So we discover that population variance doesn't have minus mu. So this is a mistake people were making. -1 is out. So it's simply going to calculate it as follows. Our 46,534 minus 1136 over 30 divided by 30. So the answer is going to be 121. The answer is going to be 121. So 121, when you square root it, we get our standard deviation as 11. Now, are we clear on this population? So the population standard deviation is given by the symbol sigma. So after we find our variance, when we square root it, we get our standard deviation. And the next question is asking us to calculate the percentage of values that fall within 2 standard deviations. So to calculate that, our formula is simply mean plus minus 2 standard deviations. So since we found our standard deviation from here, our standard deviation was 11. So we use this formula here. The mean is 37.9, our 2 there, then our 11 there. So when you calculate that, our lower bound will be 15.9 and the upper bound is 59.9. So this is the lower limit and the upper limit. So this is how we calculate it. There's no Z in this case. Then, since this is a range, they're asking us to find what? Find percentage of values that fall within 2 standard deviations. So from 15.9 to 59.9, you literally count which ones fall from 15.9. So that range. So when you handpick them, you'll discover that they're actually 28 variables. 8 variables that will flow from 15.9 to 59.9. So we're going to just cut off these 2 there. All of them are flowing through. So when we go there, they are going to be how many? 28 out of 30 times 100. So we're going to find 93.3% of the variables will fall within that range. Are we together? So after finding the confidence interval, you locate which figures fall within this range. So you discover that when you go there, you're going to handpick. The ones that you handpick are literally going to be 28. So 28 out of 30 is 93.3. So this is how we find the percentage. And the next question was asking us to find our observations that fall within 3 standard deviations. 3 standard deviations. Are we clear so far?
Yes. Yes.
All right, so you handpick them. Okay. So for 3 standard deviations, we are going to calculate them. Mu plus minus 3 ST. So ST has been calculated and our mean also has been calculated. So when we go to our calculations there, our mean was the same, 37.9, and our standard deviation was 11. So when we calculate this, we get 33. When we subtract 3 from 37.9, we get 4.9. And also 70.9 will be the upper bound. So the range between 4.9 and 70.9, when you go literally checking them here, only 73 is not there. So all of them are there. So when you count them, you're going to find 29 out of 30 observations. So the percentage that will fall within that range will be 96.7. So this is the answer that we get, 96.7. Okay. Then when we go back to our question, we are told now that the number of customers attended to by a cashier in a pharmacy in the same hour-long period is normally distributed with a mean of 31.6 and standard deviation 7.5. Identify the range of values that will lie between 75%. According to the empirical rule, 75% captures 2 standard deviations. So since our empirical rule, 25% captures 2 standard deviations, so we're going to use mean plus minus 2 ST. So where there's a mean, we've been given 31.6. Where there's our standard deviation, we've been given 7.5. So the 7.5 is the standard deviation. The 2 is coming from the empirical rule. 3 standard deviations we know falls under 97.7 and above. So here, since we're given 95%, that's where the 2 standard deviation is coming from. When we apply this and that, we're going to get 15. So 15 plus minus 31, we're going to get the range of what? 16.6 and 46.6. So this is the range. Okay, are we together on that one? So we'll then proceed to the second question, part C. Part C, you've been given the following data prices. Like I said, those who learned how to use a calculator, this is meant to steal your time. So this is meant to steal your time. So what you do is you just punch them in the calculator and all the prices will enter. Then this is about 6 marks to 6 plus 12 is about 18 marks. So once you enter your data, summary output will be as follows. Summation of x is 4584. Summation of x squared is 71.2594, and our n is 30. So your calculator can also punch directly your mean, which is 152.8 and 20.48. So you can show the working just to validate. The mean is summation of x over n, so 4584 over 30, we get what? 152.8. Then this is a sample, not a population. So to find our standard deviation, summation of x squared minus summation of x to the power 2, everything over n minus 1. So when you compute this, you're going to find your standard deviation as 20.48. So you've been asked in this question to calculate the mean and the standard deviation of the prices. So this is how we find the mean and the standard deviation of the prices. Together. Am I clear enough? Or I sound a bit distant?
Yes, you are.
Yeah, yes, sir.
Mr. Collins,
Yes, sir.
maybe at the end of the class, you can just help us with the calculator.
All right. Okay, is Clara here?
Yes, I am.
Okay, you're understanding how to get us so far?
Yes, 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 yes.
Thank you.
Okay.
Proceed now to finding the percentage of values that lie within one standard deviation around the mean. So like I said, the same formula we're using within one standard deviation, the mean plus minus one standard deviation is 152.8 and our standard deviation is 20.48. So when you multiply that, you get these figures there. So when you subtract 152.8 minus this answer, you get 132.32. When we add 152.8 plus 20.48, we get 173.28. So these are the ranges. Now they ask you what percentage of values will lie between this range. So you go there to count 132 to 173. So 132 to 173, then so 132 to 173. 173, guys, is there. 132 starts from somewhere here. So when you count these figures there, you're going to find that 21 of them will lie between 51 out of 30, which as a percentage is 70%. So 70% of these ones are the countable values that we're going to find. So we're going to find 70%. All right. So that is how we get those figures. 70% of them. Then what percentage of values will lie within two standard deviations around the mean? So two standard deviations, we get the same mean plus minus two standard deviations. So our standard deviation here, when we add our two, when we calculate that, the lower bound is 152.8, the upper bound is 40.96. So within this, we're going to find our 111 for the lower bound and 193 for the upper bound. So when you count them, you're going to find that in this here, 111 includes this in the upper bound. Then the upper bound is what? 193. So 193 includes the 99 there. So all of them except the 199. So you find that we're going to have 29 out of 30. So when you divide that, you're going to get 96.7. So these are the countable values that you're going to find within that range. So these ones are the ones that lie within two standard deviations. Then within three standard deviations, and multiply by 3, the range will be 91 to 214. So you discover that the more you increase the standard deviations, the higher the values. So 91 to 214. So all of them will be within the countable values. So with 38 out of 30, so this will be 100% that lie within the three standard deviations. That is how we get that figure. All right. Then we go to question number 2, where we're told that you notice that an officer is happy. The probability of H is 0.6. Of H is 0.6. Then we're also told that probability that he accedes to your request, given that he is happy. So whenever you see if, then just know that it's a conditional probability. So you also notice that if he is happy, he accedes to your request, that is 0.4. So how do we denote that? Probability that if he's happy. So if he's happy, there's a probability that he accedes 0.4. And also we are told that this is 4 marks. If he is not happy, then he accedes to your request 0.01. So where is the if coming from? If he is not happy, so happy complement, probability that he accedes is what? 0.1. This is a breakdown. So the probability that is happy is 0.6. So meaning the probability that is sad is 0.4. Is that clear? Then the probability that he accedes given that he is happy is 0.4. And the probability that he accedes even when he is not happy is 0.1. So remember, probability is very important to understand the narrative. The question is, you call him one day, he accedes to your request. What's the probability that he's happy? So they're looking for A and H. So what the examiner is actually looking for is the reciprocal of this probability of what? Happy, given that he accedes. Now to find that, we need to first find the probability that he accedes. So just identify the things with a similar denominator. So this one, probability of A given H, then probability of H, it will give us the intersection of the two letters as long as these are the same. Then probability of A given H complement times probability of H complement, these ones will give us the intersection of what? A intersection H complement. The two letters. When you multiply these two, probability of H and the probability of A given H, it will give us probability of what? A intersection H. So the two letters here that are common are A and here A. So when you add the probability of A intersection H and the probability of A intersection H complement, it will give us a probability of what? A. So in this case, I multiplied H times A given H to give me the intersection of 0.24. And I also multiply A given H complement times H complement to give me the intersection of A intersection H complement, which is 0.04. When I add these two, common letter is what? A. So I'll get the probability of A, which is 0.24 plus 0.04, which is 0.28. Now, how do I find the probability of H given A? The A comes down, they intersect H intersection A. So 0.24 over 0.28, we get 0.875. 0.875. So that is how we compute the intersection. That is how we compute the intersection. Okay. Then we go to the next question. We're given that medical cases indicate that different cases may produce identical symptoms. So we've been given the symptoms of H as 0.01, 0.05, 0.002 respectively. So we can call this A, B, and C. The probability of developing symptoms given illness. So H given A, H given B, H given C. So 0.9, 0.95, and 0.75. So these ones are conditional probability, which are given a particular conditions. So I told you the table is the easiest to use. So we go here, probability of H coming from A, 90, H coming from B, 95, H coming from C, 75. Then A was 0.01, B was 0.005, and C was 0.02. So when you multiply this, we're getting this computation. Okay. So you remember how I got that one. So when you compute that, get the joint probability, and also we get the posterior probabilities as follows. So in this case, I multiplied this by that. I'm going to get H intersection A. 0.05 times that, I get H intersection B, 0.00475. And 0.2 times 0.75, I get 0.015. So when I add all this, I get the common letter, which is what? 0.02875. Then if I divide 0.09 over the total, it is a posterior. A given H, 0.313. And I divide this over that, I get 0.165. And finally, 0.015 divided by that, I get 0.521. Of course, I've gone beyond my request of what the examiner is asking for. So they're asking, assuming that the person who's ill and had a symptom, what's the probability that came from A? I know you don't understand the English here, but just know that they're asking for a posterior. So they're asking for the opposite. So we're going to have our posterior. They're asking for A given H. So A given H will be A intersection H intersection A over H. So 0.09 divided by 0.02875. When you divide that, you get 0.313. So that is how we get figure. So that is how this question was supposed to be answered. Then part C, we are told that the following data shows the number of customers who have overdue accounts according to the credit type and the number of days. So we're given a standard, gold, platinum, and less than 30, between 30 and 60, 60 to 90, more than 90, and the totals have been given. Now remember, for such a table that has been given, whenever you're asked to find the probability, for instance, of gold, just get the total over the grand total, 282 over 661. Platinum, 95 over 661. If you're asking you to find the probability of less than 30, 327 over 661 directly. But if they're asking you to find between 31 and 60 over gold, so go where they meet, but the letter which is down there, gold, is the total you get. So 101 over 282. So that is just a preamble. Now the question here, what is the probability that a selected account, which is 30 to 31, is, where the is where the probability is, asking the probability of what? Of a gold card. So probability of G, given that it is what? 31 to 60. So you consider where the word is. So like I said, what is the probability that a randomly selected card, which is 30 to 61 days, is an overdue gold card? So you go where they meet. Where do they meet? Gold and 31 to 60, it's that one there. So we just put 101. The total for the bottom guy, 31 to 60. What is the total for 31 to 60? 198. So when you divide that, you're going to get, after summarizing this, gold 31 to 60, we're going to find out 101 over 198 to get 0.510. The next question is asking, what is the probability that the randomly selected gold card is, so where the is 61 to 90 given gold. So 61 to 90 given gold. So you go where they meet, 61 to 90, 61 to 90 given gold. So they're meeting here. But the total for the bottom guy, the gold, the total is 282. So it is going to be 49 over 282, which is 0.174. And the last part of the question has been asked. Determine whether the events 31 to 60 and platinum are independent. So independence, we know that there are two letters here. 31 to 60 given platinum must be equal to 31 to 60. Maintain the top guy. This one must always be maintained. Since we're doing this letters, you can, if you want, you can use P over 31 to 60. Should be equal to what? P. Maintain the top guy. You can use either of them. So in this case, I chose the bottom guy, P given 31 to 60. So how do I find P given 31 to 60? I go to where they meet. 31 to 60 and P, they're meeting on what? 12. Then the total for what? P given 31 to 60. 31 to 60 is at 10, not at 12. So P given 31 to 60 over 31 to 60. So 31 to 60 is what? 198. So 10 over 198. And I'm going to compare with the probability of platinum. Platinum is here, 95 over 661. 95 over 661. And I evaluated them. The figures were not the same. So I concluded that they are not independent. So we're together so far. So we now go to our next question. Which is question number. I haven't done with this question. So we go to the distance test. The distance test. First question, we are given 20 observations. So we're asked to find the mean, the standard deviation, the median, and the quartile range. Now, like I said, you can input the data using the calculator by pressing mod 2 and start entering them. 1m plus, 1m plus, 5m plus, going upwards until you enter all the data. So entering all the data will give us the following output. So our summation of x will be 413, x squared, 12, 3, 10, and our n is what? 20. So to calculate the mean summation of x over n, so we're going to get 20.65. Then when we go to our variance, this one is our variance. So to get the variance is summation of x minus summation of x about 2 over n minus 1. So the variance here will give us 199.08. Square root, we're going to get 14.11. So this is our standard deviation. Standard deviation is always when we divide when we square root our variance. The median is half of n plus 1. So we have 20 observations. 20 plus 1, we get a what? 21. 21 divided by 2 is 10.5. Now 10.5, it means you get the 10 and the 11 divided by 2. So when you go here, you are going to you're going to identify 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 19th and the 20th figure, you add and divide by 2. So we're going to get 19.5. So this is where the 19.5 was gotten. 19.5 was gotten. Now, when we go to the interquartile range, it is the third quarter minus the first quarter. How do you find the first quarter? A quarter of n plus 1. So a quarter of n plus 1 would be a quarter of 21, which is 5.25. Ideally, we were supposed to get the fifth one. But since according to his marking key, he's getting whatever has a point.
Colin, just a moment. Before you go further, for the second quarter, it was on 10.5, the position. So you added the 10th and the 11th which position? Oh, okay. All right. Okay.
and the 11th divided by 2.
All right. Next.
So what am I trying to say? Only when you have a 0.5, you are going to get this and the following number, the 11th number. If you have a 12.5, you get the 12th and divide by 2. But if you have a 10.25, we are simply going to, in short, anything with a point, you get that number and the following number divided by 2, whether it's 0.5 or 0.75 or 0.2, we are going to add that number and the following number and divide by 2. Although ideally, we are supposed to get the nearest whole number. But in this case, he just made your life easy. As long as there's a point, just add that number and the following number divided by 2. Is that clear? So in this case,
Yes, it's clear.
we found what? 10.5. So the 10th and the 11th divided by 2. So 19 and 20 divided by 2, we get what? 19.5. So for the interquartile range, a quarter of 21 is 5.25. So it's the 5th and the 6th divided by 2. So 9 plus 11, which is 20 divided by 2, we get a 10. Then 3/4 of n plus 1 is 15.75. So it's a 15 and the 16th divided by 2. So the 15th number was 28 and the 16th number was 31 according to this. Okay, so 28 and 31. So 28 and 31, this is where it's coming from. Together, so that's how we found 9.5. Then now to find the interquartile range, we subtract the upper minus the lower quartile. So 29.5 minus our 10, which will give us 19.5. Any questions so far? Are we moving together?
Right, we are clear. I'm clear.
Okay, great. So now we go to our next question, which is to do with question now, which is to do with us looking at the sample. So we're told that a sample has a distribution that has a single mode and strongly positively skewed. An analyst computes 3 measures of location. There's a mean, median, and mode. So which one of these 3 is the largest of the 3? So for skewness, we've been told that it is positively skewed. So whenever you're dealing with skewness, it is mean, which must be greater for it to be positive. Then suggest which one will be the best measure of location. Location is usually the median. It's the only one that is there. Q1, Q2, Q3. The Q2 is the median. I repeat. I've been given a question where 3 things have been computed: the mode, the median, and the mean. And we've been told on top of that that this one is strongly positive. So because the formula for the median, for the skewness, is given by mean minus median. So for this to be positive, obviously this one must be greater. That's the only way we get positive. So the mean must be the largest to get a positive what? Skewness. That is the reason. And which one is the best measure of location? It is a median because it's the second quartile. Try together. Right. Then we go to perhaps the toughest question in both papers, and the binomial distribution. So here we're being asked, we're told to say a company has 1,000 policies. Now, these 1,000 policies are based on past data. So the company estimates that a policy will have a probability of 0.03. So our P is 0.003, meaning our Q will be 1 minus 0.003. Then it assumes that no policy will generate more than one claim a year. Part 1, find the probability of more than 40 claims coming from a portfolio of 10,000 in a year. So this is a binomial distribution. You need to understand in a binomial, when you're given N and P, just multiply these two to get your mean. The mean is NP. So 10,000 times 0.03 will get a 30. Then the variance is NPQ. So 10,000, 0.003, and 1 minus 0.003, we're going to get 29.91. So when you square root that, our standard deviation will be 5.46. Now the question is, what is the chance that you are going to have greater than 40 claims? So here, this is what we call the binomial to normal distribution. So we're going to say greater than 40, so 40 is here. Now, because of the correction term, we're going to add the 0.5 to this one here, but it doesn't touch the 40 itself. So ideally, we're supposed to use 40 minus 30 over 5.46. If you do that, you get 1.83. But because it should be greater than 40, under binomial normal, we're going to use 40.5. So 40.5 minus 30, we're going to get 1.92. So when you read this from the table, and the cumulative table is the one that he is using, you're going to find the values for find the value 1.92 under 0.9730. Remember, if the shading is small, you subtract from what? From 1. So 1 minus 0.9730, we're going to get 0.027. If you're using the non-cumulative table, you're going to find here at 0.47 is 0. You subtract it from 0.5, you're still going to get the same figure, 0.027. All right, then we'll go to our next question here. We were told that a university has the following statistics. So that has been produced using a stem and leaf diagram. By now, you know that a stem and leaf diagram, for instance, you are given 02, 03, 04, 11, 11, 12, 13, 20, 21, 24, 25, 26, 26, then we have 30, 31, 32, 40. So I want you to learn, those of you who've never learned how to convert a stem and leaf diagram. So we have a stem and we have a leaf. So how do we come up with a stem? Identify the numbers that we have. We have numbers that start with 0, 1, 2, 3, 4. So for zeros, we have 02, we have 03, and 04. The one, we have 1, 1, 1, 1, 2, 1, 3. The two, we have what? 2, 0, 2, 4, 2, 5, 2, 6. Okay. The threes, we have 3, 0, 3, 1, 3, 2. The fours, we have 4, 0. So when you see something like that, that is a stem and leaf diagram. This should help you understand what this is all about. So this is 02, 02, 04, 05, 09, 05, or 15, 19, upwards up until 35. So can you tell me from what you can see, what is the highest number?
35.
32.
X marks what?
It's 35.
Yes, 35. And the lowest number?
02.
2. So to find the range, it is simply the highest number minus the lowest number. So 35 minus what? 2, which is 33. Together. All right, then the median is what? Given by half of n plus 1. So we know that our n has been given by what? How many observations? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16. So half of 16 plus 1, half of 17, you get 8.5. 8.5 means what? The 8th and the what? The 9th number. Divided by what? Divided by 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So what numbers are that? 15 and what? 17. And divide that by 2, we get 16. So that is how we found our median. So the lowest number, the highest number, the difference, we already got this part of the question. 33. The median, 8.5. So 15 plus divided by 2, which is 16. At this point, are we together? Are we moving together? Walia, are we together?
Yes.
Are you getting better?
Yes.
All right. Okay, then the mean, like I said, don't waste much of your time if you learned how to use a calculator, but if you don't know, just use a manual way. So when you enter all these, you are going to get your summation of x as 266 and your n there 16, and divide them, you get 16.625. That is your mean. So these are time wasting questions. Of course, 1 mark depends on your strategy. All right, then we go to part B of the question.
Mr. Collins,
Yes, please.
just to make you go back on the numbers, you said when you say 0, 0, 2, 2, 4, 0, I was behind. I was just getting to school. So I missed that part, but I understand the other, and how to find the range, the median, the mean. I understand these. Just on the table, maybe you can shed more light for me to understand.
So this is 0, this is 0, 1, this is 0, 4, 0, 5, 0, 9, this is 15, this is 19, this is 15, 17. So these numbers are just coming from what? From this figure that you have here. So this is a stem. Whatever you have there means you are this is a stem and this is a leaf. Of course, this was supposed to be rearranged starting from the smallest number. So we're going to get these figures there. We have 0, 2, 2, 4, 0, 5, 0. But fortunately, it didn't disturb the final outcome of your answers. So this number is not 1, but 31. This is 34. This is 34. This is 35. This is 15, 17, 18, 18, 19, 15, 19. So this helps you rearrange your data.
Okay. Oh yeah, I get it now.
Right.
Okay.
Then the manufacturing, this was the first question. The manufacturing company is analyzing its accident record. So we are told that we have minor. So accidents fall into 2 categories. They're minor and they're major. Minor ones, their average cost is 50. And the major, the average cost is 100. Then the company has 100 employees, of which 180 is office staff. So 1000 divided by 180, you get 0.18 as a percentage. The rest are what? They work in the factory. So the rest is 180 from 1000. What do we get? 82. So 0.82, they work in the factory. And the analysis shows that 10% of the employees have an accident each year, and 20% have major accidents. It is assumed that an employee has more than one accident in a year. Determine the total cost of accidents in a year. Okay, so the cost comes from here. So we need to calculate the percentage for the minor and the percentage for the major, then you compute them. To do that, we break down the major is 1000, the minor is 50. The office, it is 180, assuming the rest, it is 820. So when you divide that, it will give us 1000. It will give us 1000, we add them. So these ones in the office are 0.18, and these ones in the factory are 0.82. So it's asking us what component of these ones comprises of the costs. So we've been told that 10% of the 1000 accidents happen in a year. In short, 100 accidents happen in a year. But we've also been told that 20% of these ones are major. So meaning, how many are minor? 8. So just put this 20% of the major, we multiply it to the 1000. Mean the remainder is 80%, 0.8, we'll multiply it to the what? 50. That's why it was 1 mark. So what is the cost? 20% of 1000 and 80% of 50. So when you multiply that, we're going to get computation 20% of 1000, 80% of 50. The total figure will be 240. Then the other question to say, show that given that a member of the office has an accident, it is 0.0549. So this particular one, an accident given that as an officer. So given that, where you see given that, a member works in an office staff, show that the probability is equal to 0.054. So you simply divide the 10% over 0.18 times 0.82 times 2. So it will give you 0.0844. I don't want to waste so much time on this one. For some of you, probability is a problem, but those that can get 1 or 2 things, this one was a little bit delicate. So the other part of the question was asking the reciprocal. Determine the probability that randomly selected employee who has an accident is an office staff. So that's a posterior probability. So 0.0549 times 0.18 divided by the 0.1, you get 0.99. So these figures are not explained so much. I'll go to the next question. Is a little bit better. So we're told that the company consists of drivers. A are those younger than 22, B are those between 22 and 33, and C are those more than 33. Okay, so you break down the data. A less than 22, B 22 to 33, and C more than 33. So what else are we told? We are told that Group A policy holders, Group A are policy holders of the drivers, they have a policy. And Group B, 10% have Group A, 38% are Group B, they are policy holders, and 52% of Group C are policy orders. So when you see these ones, just see which ones are adding up to 100%. These are called prior probabilities. So A, 10%, B, 38%, and C are what? 52%. Then we are told that the probability of a claim in any 12 months being made belonging to any of the groups A, B, and C is as follows. So 13% a claim coming from A, 3% claim coming from B, and 2% claim coming from C. So just draw this. Claim coming from A, 13%. Claim coming from B, 3%. Claim coming from C, 2%. Okay, so when you apply this one and that one, 0.013. This one times that one, 0.0114. This one times that one, 0.0104. So when you total up, we get our total or claims, which is 0.0348. Okay, 0.0438. So this is our probability that you're going to have a claim. Then they'll ask you,
Mr. Collins, sorry, how are you getting the 0.13, 0.03, 0.02?
you're given in the question here the probability that in 12 months to make a claim. So A is 13, B is 2. When they say respectively, it follows that this one is for this, B is for 3%, and C is for 2%. So this is illustrated as claim coming from A, 13%, claim coming from B, 3%, claim coming from C, 2%. And apply this one times that one. It is a claim. Okay. Coming from A and it was a claim. Coming from B and it was a claim. So these are the figures that we have there. So when you apply this and that, we get the intersection. This and that, we get the intersection. This and that, we get the intersection. If we add all this, the total is a common data that is there throughout. What is a common data? A common data of what? Of 0.0348. 0.0348. So that is that. Then if I give you A given C, by dividing this divided by that, we get 0.374. Then this one divided by that is 0.328. This one divided by that, 0.309. So they ask you, suppose a claim was found, what is the chance that it came from A? It is 0.375. Suppose a claim was found, what is the chance that it came from B? 0.328. Suppose a claim was found, what is the chance it came from C? 0.309. So these are the figures that we're having here. Okay. So here the question is now asking, calculate the probability that one of the drivers will make a claim. So they're asking you to find the probability of C, which is 0.0348. Then the other question is, suppose a claim was found, what is the probability that it was younger than 22? So since 22 is A, they're asking you to find the reciprocal, A given C. So this is 0.374. That's how we found it here. There. This is giving us how many marks? 3 marks. All right. And the last question, which was the toughest question, told that, yeah, it's analyzing the punctuality of flights. It measures departures and arrivals. It measures them early, on time, or late. So from records, we've had no flights departing early. So departing early, DE is equal to 0. Then 85% depart on time. So depart on time is what? 85%, so 0.85. Meaning that if they're going to depart late, it's a remainder. 0.15. Then arrivals are early 10%. So arrival early 10%. 10. Then arrival late 20%. So arrival late 20%, 0.20. So now determine the probability that a flight will arrive on time. So how do we know that it arrives on time? When it departs on time. So this one, arriving on time, should be the same as if it departs on time. So if it's leaving dollar on time, you simply arrive Lusaka on time. So 0.85. That's why we're getting 1 mark there. Part 2, determine the probability that it will arrive early if it is on time. So probability that it will arrive early. So arrive early if it departs on time, given dt. Okay. So we've been told that 10% of the flights that depart on time are late arrivals. So if it departs on time and it means to arrive late, and arriving late is 10%, 0.10. Okay, so are we moving together so far?
Sorry.
So in this regard, these are the parameters of the data that we have here. So arrival on time is 0.85, meaning late it is 0.15. Arrival early is 10%. The percentage of arrival late is what? 20%. So meaning arrival on time is 80%. So part 1, what's the probability that it will arrive on time? It is simply probability that it will depart on time, 0.85, 1 mark. Then here we're being asked to find the probability that it will arrive late given that it departs on time. So it is A intersection dt over dt. So we're given that it will arrive late, intersection depart on time was 10%. This one here, divided by probability that it will depart on time 0.85. When you divide that, you get 0.118. Then here, the probability that will depart on time, intersection arrive on time, given this data. Okay, so we are asked to find the probability that to show that the probability that they both depart on time and arrive on time is 0.665. So according to my computations, it was not exact, but it was close. So arrive on time and depart on time, just multiply the two figures. It departed on time as 85% and arrives on time as 80%. So when you multiply these two, you get 0.68, which is almost 0.665. So you get that figure there. Then also determine the probability that it will arrive on time if it departs late. So probability that arrives on time if it departs late. So we got the idea that it will depart late. Because if it departs on time, it is 50%. So I mean departing late, it will be 15%. So when you're going to multiply the probability that it will arrive on time and depart late. So 0.185 times 0.15, we get 0.1275. So this is the probability that it will both arrive on time and it will depart late. This one is coming from the 85%. And finally, we are asked to determine the probability that if the flight departs late, there's a chance that it departed on time. So they're asking for you to calculate the probability that departs on time if it arrived late. So this is the probability. Okay. So finally, we go to ANOVA, where we're given the following. Number one, we're being asked to compute or describe the purpose of a one-way ANOVA. What is the purpose of a one-way ANOVA? And also the three conditions that must be met for a one-way ANOVA. So these are the small marks that people lose out because they don't want to go through. So one-way ANOVA is typically used to investigate if variations of different levels are measurable on the dependent variable. So the purpose of ANOVA is that to tell you if there are any statistical differences between three or more means. So that is the purpose of ANOVA. Now, ANOVA has a number of assumptions that you need to know. Number one, you can say that they are normally distributed. Number two, the means have equal variance. Number three, analysis of variance has so they are normally distributed. What else have I said?
Said the means have equal variance.
Equal variance, normally distributed. And third one was still waiting.
They're independent.
Independent.
So these are the assumptions of ANOVA. Actually, Timothy had mentioned it. All right. So at least you secure your marks. Then we're given this question to perform a one-way ANOVA and to test it. So to test this one, we are first going to add the totals. So the totals for each chain 1, 2, and 3. We add this, we get 28. And mainly there are 5. The square totals of each one of them, 2, 2, 2. So we're going to get 168. When you add them, we get 9. Count them, there are 5. Square each one of them, we're going to get 311. So here we add them, get 42. Count them, you get 5. Square them individually, you get 360.
Mr. Collins, for the third chain, the total I found 358.
For the third chain, if you square total each of them.
Yes.
All right, 358. Is that what the rest are finding? Anyway, let's get the concept. Yes, 358, thanks. So this is 358. So then you total up this plus that, 102, this plus that, 15, this plus that, you get this figure. So after totaling them up, you get the sum of square total as a sum of square total is supposed to be 44.93. Then that correction. So 44.93. Yes. So what would be the total here? 168, 311, and 358. What do we get? Count the three. What are you getting? 168, 311, 358. What are you-
887. 887.
Okay. So 887. When you subtract the correction term, this is called the correction term, 109 squared over 15, you're going to get 44.93. Similarly here, if you square each individual minus a correction term, you're going to get 21.73. Okay, then the ANOVA table is correct. That one confirmed it. So the ANOVA table is given by the sum of square between, sum of square within, and sum of square total. Degree of freedom is k minus 1. Degree of freedom is n minus k. Then here n minus 1. When you divide these figures here, you get our mean of squares. So F calculated is when you divide our MSB over MSW. So in this case, we're going to now use the figures we got from our ANOVA test. So our total was 44.93 and our between was 21.73. The within is a difference. 44 minus 21, we get 23. Then our K minus 1, the K is the number of populations. In this case, the number of what? Columns. So 1, 2, 3 minus 1, we get a 2. And in this case, n minus k, our n was what? 15. 15 minus 3 is where we get the 12. Then we total up there to get 14. So 2 into that, 10.87. 12 into that, 1.93. And finally, we divide the MS within into the MS between. So 19, 1.9 into 10, we get 5.6 what? 5.63. Then if I'm going to conduct a 5% test, you need to follow the procedure. Step 1, state the hypothesis. Mean 1 is equal to mean 2 is equal to mean 3. At least one is different. Step 2, at 5%, read from the table. And whenever reading the table, we need to use what? These coordinates. The coordinates are 2, 12. How do we read the tables? Read the tables by checking, because the 3 tables that we use for ANOVA. So these are is what we call the 5%. There's a 1% and a 0.1. So we use our column to check the 2 and the row to check the 12. Okay. So
Mr. Collins, are you displaying the statistics table?
I'm looking for it. It's one I'm looking for right now. So that's
We use the F table, yes?
yes, we use the F table. So when you go here, F table is the one you use for ANOVA. Then you check. There's a 0.1 table, is a 0.1 table continued. Is a 1% table. I can give you any of these percentages, be careful. So check. The percentage is the title of the table. So if it's 5%, 5 where they meet, 2 and 12 where they're meeting, 3.89. 3.89. So that is where our figure is coming from, 3.89. So when you read that 3.89, you compare now the figure you got and the statistical table. This one is never a two-tailed, just one-sided there. So don't shade both sides. So you're just comparing 3.89. Compare what we calculated as our F calculated, which is 5.63. 5.63 is somewhere there. So when you divide, or when you identify it in there, it is in the shaded region. So we're going to reject our HO because in the shaded region, was this accept region? And this is a reject region. So since our answer is falling in there at 5%, since F calculated is 5.63 is greater than 3.89, we reject HO and conclude that there exists a difference in customer satisfaction.
Excuse me, Mr. Collins.
Is it?
At what point do we divide the alpha by 2? Is it stated that is it stated in the question to say if it's a two-tailed test, then we have to divide by 2? Do they state that this is it's a two-tailed test?
No, they don't state whether it's a two-tailed test. You just need to know. So I made statements for you to say regression is always a two-tailed. Number one, estimation is always a two-tailed. Where there's a one-tailed test, it's just ANOVA and hypothesis test in certain instances. I'll explain. So for this one, don't divide anything, just redirect. Because even as you see the
Okay.
table, you can see that the table, although it's not showing, but some tables show that it looks skewed to the left. All right. So this is our conclusion. All right, then now we can go to regression. Are we together on the ANOVA?
Yes, but is it always that we need to reject if the F calculated is greater than the one we found?
Yes, we always reject. So whenever we reject,
Can we?
you need to also understand that whenever we reject, it means that there's a statistical significance or difference. So whenever we reject, there's something happening. Yeah.
Okay, thank you.
Any other questions before I proceed?
Before we proceed, just run me through the purpose of ANOVA. I only got one. It's independent. Is it the data are independent?
Okay, that's not the purpose, but the characteristics. The independent, who else?
Oh, the conditions, the conditions.
You remember the other two?
In my own understanding, these, I don't know if they are correct. There is, I wrote, they have the same variance.
Yes.
The other one, each level have a normal population distribution.
Yes, a normal distribution, yes.
Oh, okay.
All right. So
All right.
we can go to regression. Okay. Are we ready for regression? Okay, so we go to regression.
Mr. Collins,
Yes, please.
on the H1 for ANOVA, instead of saying M is not equal to M2 is not equal to M3, you can just say at least one is different.
Yes. At least one Yeah. So we're going to look at tutorial sheet number 8, which has 2 things there. But before we go there, maybe I hope we are familiar with balancing up and ANOVA. So at least we did the balancing up of ANOVA questions. So we know what to divide where and what to divide where. So in this question, we would be asked to balance up the missing stuff. So how do we find the missing value here? We subtract the 2, right? How do we get this quickly? 72.11 minus 56.68, what do we get?
15.43.
0.43. Then the difference here is
20.
20. This one in there. Into 50.68.
2.8.
Then divide this into the 4.
1.43.
1.43. So if you're asking you to test this at 5%, to test whether it's significant, you read this under 4.20. So from the table, we're going to read this 4.20. So 4.20, 2.87. 2.87. 2.87. What is our conclusion there?
We
We
fail to
reject.
reject.
We fail to reject because the F calculated is less than the one we found.
Okay, so we fail to reject. So that is the decision. So here, let's quickly balance up. How do we get the difference here?
Or 67.81 within
467.81. Then here,
3.
3, 10.
And 39.75.
What?
139.75.
39. 139.
0.75.
Then here,
24.6.
and 4.6. Then you divide this in there, what are you getting?
5.68.
Pardon?
5.68.
68. Okay. And do you read the coordinates? How do you read the FQ?
3.19.
So when you go to check 3,19 here, what is the reading?
Is it always on 5%? Since we're not given, are we going to assume it's 5% always?
You're not given, yes. 3,19 is what?
3.13.
3. So what is our conclusion? Decision?
We reject.
We reject.
All right, that's good. Reject, meaning there's statistical significance. All right. So we can go to,
Okay, no, it's fine. I wanted to ask something. Well, other questions can find the total number of observation or find the total number of population.
okay, that's a good one. How many observations are there and how many populations are there? We just add a 1 there. Population.
Yeah, that's 5.
Then observations.
And then on the total,
At 25.
that's 25.
Okay. Therefore, observations are what? 23.
23.
Yeah. All right. So now again.
Collins, a question. So for this, the F table that we use, because we use the degrees of freedom, so maybe it would be 2,9 or something like that. So does that mean
so two, like this one,
percent or the different F tables for different percentages?
Yes, this table is a percentage.
Yes, for example.
This table is a 5% table.
Pardon?
If you can see the table,
okay, so they
5% table, which is a standard. If you're not given in table,
okay.
Then there's also a 1% table and also another 0.1 table. So these are only 3 tables you have. So the percentage is the title of the table.
Okay.
Is that clear? Okay, then finally we go to it's 12 hours now. So regression, you've been given the number of hours and the exam score. In the direct, our X is what? Number of hours. The exam score is our Y. So when you put them in here, X and Y, we multiply them and we square them. Our summation of X is 21. 5, 16. These are the totals. And calculate the correlation coefficient between the hours studied and the exam score. It's given to you. When you substitute it, you're going to get 0.862. 0.862. If that's done, you now need to explain that they are positively related because there's a positive answer there. Then go to testing at 5%, that R is equal to 0 or R is not equal to 0. If it's equal to 0, there's no relationship. If it's not equal to 0, there's a relationship. So from these pairs, we get that our pairs are 6 there. 1, 2, 3, 4, 5, 6. And at 5%, this is a two-tiered t-test because the sample size is less than 30. Now, when we divide this by 2, 0.05 divided by 2, it will be 0.025. Then when we subtract 6 minus 2, it will be 4. So we are reading the t-table. You go under what? The table that you have should read t. So t distribution. 5% divided by 2, 2.5 under 4. 6 minus 2 is 4, so you get 2.776. However, your tables will just have decimals. So what you do is simply check where the 0.025 and check under what? 4. So it will be 0.776. If that is done, you now go to putting them in the table, the negative value, the positive value is same. So once you do that, our R is R 1 minus R squared over n minus 2. So this minus 0.862, 1 minus 0.86 to the power 2. then 6 minus 2. When you compute this carefully, you'll find 3.4. Then identify where 3.4 is. It's in the our shaded region there. It's called the rejection region. And this is the accept region. So since it's in the shaded region, we're simply going to at 5% reject HO and conclude that hours affect exam score. 7 marks for this.
Do they also provide the test formula?
No.
In the in the exam, they don't.
All right.
Question.
With that, we need to know this formula in short. Okay. Any questions so far? Are we getting better? I hope you're not panicking.
We are panicking.
Yeah.
They're panicking, and the fact that they don't. So there are certain formulas that they don't provide. So,
Yeah.
like you have said, testing they don't provide.
But
What else?
The rest is there.
All the rest is there. I don't know. What's what today? Testing formula.
I think on the test is there. Now it's very complicated. This one is better.
Okay.
Okay. All right. So now we can also go to some other easier probability just to, otherwise I'm done with my task now. I think this was what I needed you to know.
Mr. Collins.
Yeah, please.
Maybe you can just take maybe even 2-3 minutes just to explain using the calculator to find the mean, the standard deviation, and yeah.
Okay, so if you're given our values as follows, and you're asked to define what a random variable is and the types of random variables that are used in statistics. Who remembers what a random variable is and the types of random variables that are there?
I can
Continuous
try.
variables, discrete variables.
The binomial.
Yeah, the binomial distribution.
So,
And the poison.
so the
Continuous.
a random variable is a numerical quantity that is generated by a random experiment. Okay. So there are several examples of random variables that you can know.
Mr. Collins.
Variable, there's a continuous, there's a binomial, there's a Poisson. So these are all examples of what? Random variables. So you'll be given construct a random variable. For instance, you're given 0, 1, 2. And the probabilities are 0.25, 0.50, and 0.25. And they ask you find the probability of at least 1. It means 1 and above. So you're going to add the 0.50 and 0.25. At least 1 means what? 1 and above. So this is going to be 0.75. Okay. They also ask you to find maybe the mean and a standard deviation. So this is called the expected value. Expected value is given by mu, summation of x, summation of x px. So if you're given values like that, how do we find the mean? Just multiply -2 times 0.21, 1 times that, 2 times that, 3 times 0.5 times that. So when you compute all that, that is called our mean, which is 1.135. All right. Then you sometimes be asked to calculate the expected value from a scenario question. We asked to calculate the expected value from a scenario question. So how do we get scenario questions in that regard? So they go for under what we call the random variables. So let me take you through my question bank where we're given a similar random variables. So we're given a scenario where we are told that the predictions of whether it will rain, it will not rain. This one here. So we're told that the pump operator sells on average 80,000 of petrol on a rainy day and 90,000 on a clear day. So we have two states of nature. Number one, we have a rainy day. Number two, we have what? A sunny day. So prior probability of a rainy day, or maybe we get the return or the expected average. So a value of X. So value of X on a rainy day is how much? Let's start with the 80,000. 80,000 is worth of petrol on a rainy day. So rainy day, 80,000. So put 80,000 here. And we're also told that on average 90,000 on a clear day. So this is clear day. 90,000. And we're also told that from statistics, 76% or 0.76 is for clear day. So they swapped it. Now you start from here. 0.76 is for a clear day. And 24% for a rainy day. So 0.24 rainy day. They ask you find the expected value. So just find P X P X. So you multiply this one times that, this one times that one, then you total up. What we get is what? XPX, which is our value. So what are you getting? 0.24 times 80,000.
1,920.
1,920. Then
No, or 90, it will be different if you are finding this 19,200.
19,200.
Yes.
Times that.
68,400.
6,840.
Not 68,400. There are zeros there. So
68,400.
yes, to mess up the WASIS, just check your calculator, Mama.
When you top up, when you add this to what you get?
87,600.
87,600. So this is what we call our expected value. Okay. So in a certain town, we have 50% males and 50% females. So we have our gender. Males are 50%, and the females are what? 50%.
50%.
Probability. We are told that of those that are males, 20% are unemployed. So conditional probability, unemployed coming from the males, 20%. So we put 0.2. And unemployed coming from the females is what? 0.05, which is 5%. Okay. So this is the conditional probability. Conditional probability. So let's do the joint probability when you apply these two. What are you getting?
.1 on the joint.
0.25.
0.025. 0.125.
When you apply this and that, this will be M union intersection. M intersection unemployed. If I apply this one and that one, it will be females employed. In the total up here, the common letter is U. So this is a proportion of those that are unemployed. When I divide 0.10 over U, so 10 over 12.5, I get 0.8. So this is the opposite of this, males who are unemployed. So it is male given unemployed. If I divide 0.025 over 0.125, I'll find females who are unemployed, which is 0.2. Let's add up to 1. So the question is, find the probability that the person who was unemployed was a male. 80% or 0.8, 5 marks. Coming from here. Find the probability that the person who was unemployed was female. 20% or 0.20, 5 marks. And you end there. So that is what was supposed to be done. Okay. So done all the assignments and all the tests. Next one here, we are told that calculate the average ratings given that there are 4 locations which are showing the ratings of satisfactions. And we are given that the ratings here, say the letter, the number of customers, letter F. When we apply, you get XF. So 7.8 times 117, you get the answer there. The total here is your N. So quickly, this times that, what we get? The ladies total, no, the gents total up here. The ladies multiply this by that to get the totals there. So that from behind, from down here, from on top. Then the guys just do this. So we are fast. Don't total up here. That's a mistake people make. Just total the frequency. So the average is called the mean. It's simply summation of X over N.
4.6.
What do we get here?
912.6.
12.
912.6.
912.6. Yeah.
361.
Here 361.
On N, yes.
731.
The per usual.
448.8. 448.8.
44.
Yes. 8.8.
Even just.
Even just. 3.6.
6. Are you sure 448.8? And what's the total?
Yes.
2758.4.
What's the data?
2758.4.
So 2758.4 divided by 361. What do we get?
7.64.
64. I'll find our mean. 3 marks. All right. So lastly, we look at the calculator, how to use it. It's a sum. Which calculator are you using?
Casio.
Okay, so I don't know that I can send you a video of how to use a calculator. I explain it here. So
And the video. I think the video is okay, so that everyone can see it.
all right, okay. So I will end here.
Collins, before you go, could you go back to the previous question?
What was the previous question about? So I hope you know how to find the mean. The question, previous question, what were we talking about? So when you're given the mu and the standard deviation, and you're given a sample size. Okay, so where you're not given a sample size, step 1, we illustrate. Our mean is what? That's 7.5. And our X here is 48. So probability that it will be more than 48 hours. So more than means shade to the right. So we standardize this X minus mu over standard deviation. This is 48 minus that 7.5 over our standard deviation is 7.6. That's our Z.
One 1.38.
What?
So 1.38. I've discovered that he uses a cumulative table when he's doing his solutions. I hope he's the one he will bring even during the. So 1.38 and 1.
So does it mean we concentrate with one minus something if you're using the cumulative table?
Since I taught both of them, better know both of them, but I've noticed most of his solutions, he is using this table. So 1.38, 0.9162. So we're going to subtract minus 1. All right, because it is what? It is a small shading. So to find the probability of X greater than 48, or is subtracting from 1, because it is what?
Because it's a small shading.
9162.
What shading?
What do we get?
0.0838.
Okay. Then the next one was what? Find the probability that is younger than 44. The word younger is synonymous to what? To less. So younger than what? 44. So here our mean was what? That's 7.5. 44. Where are we shading?
To the left.
Using ISA. What's the next step? Illustrate, standardize, shade. So what is standardize the 44? 4 minus what? 7.5 divided by standard deviation of what? 7.6. What we get?
0.86.
0.86. Okay. So when you read 0.86 from the table, 0.86, so 8, then 6 there. What are you getting? 8051. 8051. So what are we going to do?
We leave it like that.
Because it's a big shading, right?
Yeah.
And finally, between 46 and 54, 46 and 54. So our mean is at what? That's 7.5. So 46 and what? And 54. Since on one side is an interval, you standardize this one and standardize that one, and the difference between their Z probabilities. So 54, what is the Z? 54 minus the 7.5, and from the 6 minus 7.5 over the standard deviation of what? 7.6. Are you getting?
For 54, it's 2.17.
2.17. For 46.
1.12.
We round off the nearest two decimal places for you to read properly. So if they're on one side, you will subtract the Z larger minus the Z small. So our larger figure is what? 2.17, and our smaller figure is what? 1.12. So you subtract their probabilities. So here, 2.17. So 2.1 under 7. Reading is what? 9850. So 850, 0.9850, 1.12, 1.1, under 2, 8686. When you subtract these two, the difference is your interval, which is what?
0.1164.
0.1164.
Sorry, how did you get 1.12 and 2.17?
So we standardize these ones here. For 54, we subtracted 54 minus what? That's 7.5 divided by the standard deviation 7.6. Then for 46, as for 46, we subtracted 46 minus what? That's 7.5 divided by 7.6. That's how we found the figures. In the case that
Okay.
the number that was on the left side here, maybe we had 36. Obviously, Z for 36 would have been what? Smaller. So what we have done is you get the Z for this one and the Z for the other one, add them and subtract the 1. That is how we get the intervals for using a cumulative table. If it's a non-cumulative or a half table, just feed them directly and add them. At this point, I wish you God's grace to go before you. Don't get confused. I know some of you don't want to let go. You'd rather go with me in the exam while still learning. but you only have a few minutes now to yourself.
We should just go within the exam.
Okay, thank you. Oh, thank you. Oh, my, even my brain is
Thank you,
scattered
Mr.
now.
Collins.
Thank you.
Thank you, Mr.
Thank
Collins.
you.
The best and have.
Thank you.
All right, bye-bye.
No, you've really sacrificed a lot, so we will not fail.
No, you shouldn't.
Thank you for your efforts.
I appreciate you all. Have a good.
Okay.